Welcome to preparation strategy for TSPSC regarding RCC and PSC. Myself, P. Soma Sekhar. I deal RCC and PSC. I think some of you are already attended my classes and still one batch is remaining. For them also it is useful. Right, let us start. First thing, weightage of this subject. In 2016, you will find there are 19 questions asked from this subject, RCC and PSC together. Even in 2019 also they have asked 19 questions. So this year also more or less 15 to 20 questions you can expect. Okay? Right. Coming to the syllabus, RCC and PSC. Concrete structures, materials like cement, aggregate, concrete and water. Then permissible stresses in both concrete as well as in steel, and IS specifications, Indian Standard Code specifications. Then working stress method, limit state method. Under limit state method, clearly mentioned stress block, parameters, design of beams, slabs, columns and footings, design for shear and torsion, design of retaining walls, water tanks, T-beam slab bridges, yield line theory. Mostly you will expect one question from retaining walls and one question from water tanks, compulsory. Here you will spend less time for these two chapters, retaining walls as well as for water tanks. Hardly you may take for each chapter 1 hour, not required more than that. Okay? Even questions also, straightforward questions, simple questions, easily you can answer. Don't neglect these two chapters. Then remaining, working stress method. Most of the students will ignore working stress method, but questions they will ask from working stress method also. So don't ignore working stress method. Coming to the limit state method, here mentioned design of beams, slabs, columns and footings like that. Designs they don't ask. Design parameters they will ask, like minimum steel, maximum steel, minimum spacing, maximum spacing, minimum diameter, maximum diameter, etc. etc. Okay? This type of questions from design they will ask. They don't ask complete design. Design parameters they will ask. Then pre-stressed concrete. From pre-stressed concrete, basic concepts, materials for pre-stressing, losses in pre-stress, classification of pre-stressing system, then analysis of pre-stressed concrete sections. From losses, one question compulsory. It will also take very less time because it is a small chapter. Don't ignore it. Analysis of pre-stressed concrete section. One question compulsory from this one also. Minimum, I am telling, minimum to minimum, one question you may expect. Right? So, to understand analysis of pre-stressed concrete, if you have basics from strength of materials like direct stress and bending stress, if you know these two things, easily will understand analysis of pre-stressed concrete sections. No need to worry about that. Minimum to minimum, 4 questions you can expect from pre-stressed concrete. Okay? From materials, you may expect 2-3 questions, right? Remaining from RCC, more number of questions you may expect. Okay, na? This is the syllabus mentioned in TSPSC for AEE. Okay? Then coming to the preparation strategy. Which one I have to give more preference and what will be the second priority, like that. If you refer previous year questions, nobody help required. Okay? Even if you are not going to refer previous year questions, my dear, I am telling you, you follow like this from my notes. Okay? First one, IS codal specifications. First priority you can give it for IS codal specifications. Just now I told minimum steel, maximum steel, minimum spacing, maximum spacing, minimum diameter, maximum. These are the codal specifications. Minimum number of bars, minimum thickness of slab. This type of questions. This type of codal specifications they will ask directly as questions. So you will get more number of questions from codal specifications. After that, you can give priority for simple definitions like effective depth, then lever arm, then shear span, limit state, this type of simple definitions. Maximum 2 lines will be there, right? That type of definitions you can prepare. After that, you can come to concepts. From 3 areas, questions will be asked. From these 2 areas, more number of questions will be asked. From this area, they will ask less number of questions. If you are answering these questions along with these 2 means you are a ranker. If you are answering these 2 only means okay, you are very close to safe zone. If you are solving questions from concept based also along with these 2, then definitely you will be in safe zone. You are one of the ranker. You will get the post, no doubt. Okay, na? It is not good to discuss chapter wise which topics you have to prepare, which topic you have to ignore. That is not correct. That's why I am not going to take chapter wise. You have to prepare from every chapter. Give priority like this. Okay. You have to write down the formulas at one side. Okay. And solve the questions simultaneously. Related to that formulas, if any questions are available, you try it. That is more than sufficient. Okay, na? Let us see here some of the questions, how they are going to ask in AW exam. Just as per my knowledge, I picked up few questions for the given duration. Okay? And also I'll tell you how to tackle numerical questions, how to answer quickly questions, how to eliminate the options. Like this, few points I'll tell you as per my knowledge. Okay? Right. Let us come to the questions now. Model questions. Don't think that same question will be asked. Similar questions you may expect. If same question asked, you are a lucky person. Okay, na? Right. See the first question. Modular ratio of M20 concrete is. Modular ratio. Sometimes definition will also ask. Modular ratio can be defined as E strong by E weak. We are using in RCC 2 materials. One is steel, another one is concrete. Correct, na? Right. In these 2 materials, steel is a stronger material, concrete is a weaker material. That's why we can write down ES upon EC. But this formula we are not using in working stress method. Okay. We are not using ES upon ECE also. We are using one empirical formula, that is 280 upon 3 sigma CBC. Modular ratio M is equals to 280 upon 3 sigma CBC. Now, M equal to 280 upon 3 times sigma CBC we want. Here mentioned concrete grade is M20. For M20 grade concrete, from the table, sigma CBC value is 7 Newton per mm square. I said, remember for M20 grade concrete only because as per latest code, minimum grade of concrete used in RCC is M20. That's why remember at least for M20 grade concrete, sigma CBC and sigma CC values. Remaining values not required to remember from that table. You remember better the factor of safety. From that you can get it the values of direct tension and bond stresses. Mostly they are not going to ask direct tensile stress and bond stress values. Okay. Maybe they are going to ask sigma CBC value or sigma CC value. Okay. It is 7. Now substitute here 7. Simplifying this one is a difficult. 280 upon 21 we are getting. Simplification is a difficult. So we can take instead of 21, it is 20. Easy to simplify. 0, 0 gets cancelled. 2 1s are, 2 14s are. So answer will be very close to 14 but not exactly 14 because we have taken approximation as a 20 instead of 21. If you observe the options very close to 14, that too it is less than 14. Important, less than 14 because here denominator value we have taken lesser. So we are getting higher value. So definitely answer will be less than 14 but close to 14. Less than 14, close to 14, only one option is there, that is 13.33. So option is 13.33. Okay, now answer is 13.33, option is C. Okay, whenever the question is the simplification part is complicated, then better to take nearest a round figure, then simplify it. Very close to that value will be the answer. Okay, na? Pick up like that options. Then coming to next question, in a concrete structure, the ratio of permissible stress in bending compression and direct compression is. They are asking ratio of permissible bending compression to permissible direct compressive stress in concrete. How do you get sigma CBC value? By taking factor of safety 3, right? Similarly, direct compressive stress you can get by taking factor of safety 4. Now simplify, FCK gets cancelled. After simplification you will get 4 by 3. Here 4 by 3 is not there. The values given 1 to 1.5 like that options given. So this value if you simplify you will get 1.33 which lies between 1 and 1.5. This 4 by 3 value is 1.33 which lies between 1 and 1.5. So option B is correct. Option B is correct. Okay, na? Is it clear? Right. Next one. When earthquake or wind load is taken into account, either earthquake load or wind load is taken into account, the permissible stresses in working stress method are increased by. It is a famous question regularly asked in state exams, right? It is a direct value 33 into 1 by 3 percentage. Why do we increase the permissible stresses either in concrete or in steel? Why do we increase it? For economical design. For economical design we can increase the permissible stresses. Okay, option A is correct. Then move to next question. The effective depth of singly over reinforced section is 300 mm. Effective depth given 300 mm with the neutral axis at 120 mm. Which neutral axis they have not mentioned, let us consider it is X. Below the top, if the maximum stress induced in the concrete is 5 megapascal, let us say maximum stress in concrete is 5 megapascal and modular ratio is 18. Modular ratio given 18. The stress developed in steel would be, my dear, this type of questions how to tackle. Very simple, you can draw the stress diagram. You can draw the stress diagram, then easily you can simplify it. Wait a minute. the stress diagram. Okay. Here it is the maximum stress in concrete. Here the stress in concrete at the level of tension steel that we have to find out. Say it is a stress in steel upon modular ratio given here 18. In tension zone, we don't consider strength of concrete, that's why no stress diagram. But for concrete in compression zone, we consider the strength of concrete, that's why we have taken full line. It is neutral axis position. They have given depth of neutral axis is 120 mm, right? And effective depth of the beam given that it is 300 mm. They are asking to find out what is the stress developed in tension steel. Very simple. You can take similar triangles from the stress diagram. You will get the stress in tension steel. From similar triangles property, we can write down T upon 18 upon 5. What is the distance from neutral axis to till centroid of tension steel? That is 300 minus 120. 300 minus 120, it will come around 180 mm, right? Yeah. For this stress, distance is 180. For this stress, distance is 120. What we want from this? How much is the stress in steel? Okay. 180 upon 120 into 5 into 18. If you simplify this, you will get 0, 0 gets cancelled. 6 2s are, 6 3s are, 2 1s are, 2 9s are, right? So, if you simplify this, you may get 135 Newton per mm square. Not required calculator. Not required calculator, right? 135 Newton per mm square. Option B is correct. Here they asked stress in steel. Maybe you can expect a question like this also. By giving stress in steel, they will ask stress in concrete. Okay? Or by giving stress in concrete and stress in steel, they may ask depth of neutral axis. Okay, na? Right. Next question. In a singly reinforced beam, if the stress in concrete reaches its allowable limit later, be careful with the wording in the question, then the steel reached its permissible value, the beam section is said to be. Options given here: A, under reinforced, B, balanced, C, over reinforced, D, critically balanced. We have only 3 sections: balanced section, under reinforced section and over reinforced section. There is no critically balanced section. Here, even balanced section also wrong option, because for balanced section, stress in concrete as well as stress in steel, both will reach to their permissible stresses simultaneously. But here, one of the stress is reaching to its permissible value first. So it is not a balanced section. Maybe it is option A or it is option C. Okay, na? Here later, stress in concrete reached later to its permissible stress. That means stress in steel reached to its permissible value first. If stress in steel reached to its permissible value first, then it is under reinforced section. Then it is under reinforced section. Option A is correct, but option C is wrong. Is it clear? If stress in concrete reaches to its permissible value, then stress in steel, which is considered as a over reinforced section. But in this question, they mention stress in concrete reaches its allowable value later than stress in steel reached to its permissible value. So it is under reinforced section. Option A is correct. Here, my dear, I told for 3 different types of sections. So you have to check it. Suppose one question is asked for under reinforced section, your duty is checking for other sections also. Okay, na? Right. Next one. Flexural collapse in over reinforced beams is due to, in which beam? Over reinforced beams. Okay. Here, over reinforced section failed in compression because concrete is going to fail first, which is failed under compression. So option D is wrong. It is not related to flexure. Bond is a separate concept. It is not related to flexure. So D is wrong. Then primary tension failure. Suppose in place of over reinforced section, if it is given under reinforced section, option C is correct. But they have not mentioned under reinforced section, that's why C is wrong. Either B is correct or A is correct because they mentioned over reinforced section. So it fails under compression. Which is correct? Primary compression failure or secondary compression failure? Secondary compression failure is due to secondary effects. Due to secondary effects like shrinkage, creep, temperature change. These are the secondary effects. Then primary compression failure is due to bending moment. Due to bending moment. They asked flexural collapse in over reinforced beams is due to, it is due to primary compression failure. Okay, right. Option A is correct. Next question. Doubly reinforced beams are preferred. When do you prefer a doubly reinforced beam? Generally, we prefer a doubly reinforced beam when size of the beam is restricted, when the beam is subjected to reversal of stresses, when the beam is subjected to impact load, to counteract a hogging moment at intermediate supports, to get a higher ductility, and to minimize the secondary effects. In these situations, we can recommend a doubly reinforced beam, right? Here, given options A, when the depth is restricted due to headroom, etc. Yes. B, when there is a chance for stress reversal along the length of the beam. Yes. C, both A and B are correct. D, none. Both A and B are correct. In these two situations, we can recommend a doubly reinforced beam. Both are correct. To pick up doubly reinforced beam or to design doubly reinforced beam, these two situations we can consider it. Okay? For this situation, we have to go for doubly reinforced beam. Even for this situation also, we can go for doubly reinforced beam. Right. Next one, depth of neutral axis for a doubly reinforced section is 20 centimeters. Depth of neutral axis given 20 centimeters. The compression steel is being placed at 40 mm below the compression edge. If the maximum compressive stress in concrete is 5 Newton per mm square and modular ratio given 15, the stress in the concrete at the level of compression steel is given by. How do you find the stress in concrete at the level of compression steel? It is a stress diagram. Wait a minute. It is the stress diagram above neutral axis. They have given that depth of neutral axis is 20 centimeters. We can write in mm, 200 mm. And they have mentioned that 40 mm. at 40 mm compression steel is being placed, that is effective cover. Okay, this is 40 mm. Compression steel being placed at 40 mm. And the stress in concrete given that 5 Newton per mm square. Modular ratio given that 15. And what is the stress in concrete at the level of compression steel? How do you find this? Once again, consider similar triangles. Consider similar triangles. From similar triangles, we can find out C dash. From similar triangles, we can write C dash upon 5. For C dash, what is this distance? This distance we want. It is 200, it is 40. 200 minus 40, it will be 160 mm. Okay. So, 160 upon, for 5 Newton per mm square, what is the distance given here? 200. So, simplify this. What you will get after simplification? 0, 0 gone. 4 4s are 4 5s are 5 5 gone. So, you will get C dash equals to 4 Newton per mm square, or you can say 4 megapascal. Options given 5 megapascal, 4 megapascal, 3 megapascal and none of the above. Option B is correct. Suppose if they ask question, what is the stress in compression steel? Then how do you find? Stress in compression steel solution is 1.5 m times C dash or 190 megapascal. 190 megapascal, whichever is smaller. You can find here 1.5 m is, what is a m? 15. 15 into, what is C dash? C dash we are getting 4. So we get 90 megapascal. Let us compare 90 megapascal and 190 megapascal. You can take it smaller one. Smaller one is 90 megapascal. Suppose if they ask stress in compression steel in a beam, then you can find out like this, 1.5 m into C dash. Okay na? Right. Next question. Equivalent area of steel in compression is m into ASC, 1.5 m into ASC, 1.5 m minus 1 into ASC, 1.5 m plus 1 into ASC. They are asking equivalent area. Let me give you here area of steel, transformed area, and equivalent area. Equivalent area. What happened? Yeah, fine. Area of tension steel, AST, transformed area, just multiply with the modular ratio, you will get transformed area, means only conversion. Then equivalent area, which means effective area, it is m into AST only. Why do we get same area only? Because in tension zone, we don't consider concrete from strength point of view. For strength calculation, we don't consider concrete. We consider only steel in tension zone. That's why transformed area and equivalent area you will get same. For compression steel, area be the ASC. Transformed area means conversion from steel to concrete. Then what is the effective area? That is equivalent area for compression steel. 1.5 m minus 1 into ASC. How do you get this? Actually, you have taken steel outside and converted into concrete. You are getting 1.5 m into ASC. In compression zone, concrete is effective. We can't neglect the concrete. Okay. So let us fill up the concrete because you removed the steel from the beam section. Here compression steel is there, here tension steel is there. You removed the steel and converted into concrete. Once after converting into concrete, in compression zone, you have to fill up the concrete. What is the remaining area? 1.5 m minus 1 into ASC. 1.5 m ASC. Here, how much concrete area is not present? Whatever steel area present. What is the steel area? ASC. So 1.5 m ASC minus ASC will give the equivalent area to the compression steel. So option C is correct. Okay na? Right. Next one. The stress strain curve of the concrete as per IS 456-2000 is options given. A perfect straight line up to failure. B, straight line up to 0.002 strain value and then parabolic up to failure. C, parabolic up to 0.002 strain value and then uniform up to failure. D, linear up to 0.002 strain and uniform up to failure. It is the stress strain curve of concrete given in IS 456-2000. This is stress axis, this is strain axis. It is parabola up to 0.002 strain, then constant till failure 0.0035. Right. It is for cube. Let us say strength of cube is FCK. In a structure, you can take it. Strength of concrete recommended by code is 0.67 FCK. Okay. For a design, the strength of concrete is 0.446 FCK. Okay, fine. They are asking the stress strain curve of the concrete as per IS 456-2000. It is parabola up to 0.002 strain. It is parabola. Beyond that, it is constant till failure. Option C is correct. Parabolic up to 0.002 strain value, then uniform up to failure. Okay? Right. Next question. In LSM, LSM means limit state method of columns, the partial safety factor applied to steel and concrete are, remember, not only for columns, for any structural member under limit state method, partial safety factors used for materials are same. Okay? Partial safety factors used for steel is 1.15, for concrete 1.5 in limit state method. Under working stress method, partial safety factor used for steel is 1.78, for concrete it is 3. But here clearly mentioned limit state method, so you can take it partial safety factor. For steel is 1.15 and for concrete is 1.5. Option C is correct. Don't worry about the columns. For all structural members, same partial safety factors to be recommended by IS 456-2000. Okay, next question. If the characteristic strength of concrete FCK is defined as the strength below which not more than 50% test results are expected to fall, the expression for FCK in terms of mean strength FM and standard deviation S would be, yes, generally to express characteristic strength, mathematically we can take normal distribution curve. We can take normal distribution curve, which is like a bell shape. This midpoint indicates that mean. X-axis representing strength, then y-axis representing frequency. Y-axis representing frequency. Okay. Here. Wait. As per the question, 50% of test results are expected to fall. If it is 5%, mathematical relation is different. If it is 50%, mathematical relation is different. Up to hatched portion, we can consider it is FCK. Up to midpoint, we consider as FM. Okay. So for this question, option C is correct. Option C is correct. Sir, suppose if it is given in the question 5% instead of 50%, then at that time FCK equal to FM minus 1.65 times sigma. But here notations they have given for standard deviation is S instead of sigma. Okay, we can take at that time yes. It is for characteristic strength. For characteristic load also sometimes they will ask, that is Fm plus 1.65 times sigma. It is for characteristic load, it is for characteristic strength. Okay, don't confuse strength minus load plus. Load should be taken always higher than mean load. Strength should be taken always lesser than mean strength. Okay, fine. Option C is correct for the given question. Next, the maximum strain in the tension reinforcement in the section at failure shall not be less than. What will be the strain in tension steel at the time of failure? Strain in tension steel should be equal to, should not be less than, should not be less than yield strain, should not be less than yield strain. What is the yield strain value? It is 0.002 plus 0.87 Fy upon S. Here they mentioned strain in the tension reinforcement. Okay, so option A is correct. Sometimes instead of strain in tension reinforcement, they will ask strain in concrete. At which strain concrete will be failed? Strain in concrete reach to its ultimate strain, that is 0.0035, then concrete will be failed. At the time of failure, the strain in concrete will be 0.0035. This is under flexure. It is under flexure. Okay. Similarly, the strain in concrete is 0.002 under axial compression. Under axial compression, at the time of failure, under axial compression, strain in concrete will be 0.002. Strain in concrete will be 0.0035 minus 0.75 times epsilon m. It is under axial compression and bending moment. You may expect in this 4 anyone, strain in concrete under axial compression, or strain in concrete under axial compression and bending moment, or strain in concrete under bending moment, or strain in tension steel at the time of failure. In this 4, you can expect any one. Okay? Right. Here for the given question, option A is correct. Next one. For steel of grade Fy equals to 500 Newton per mm square, the value of XU max upon D. My dear, what is XU max here? XU max is limiting depth of neutral axis, which is 0.0035 upon 0.0055 plus 0.87 Fy upon Es into D. This is XU max. They are asking XU max upon D. That too for 500 grade steel. Fy value for Fe 500 grade steel, Fy value is 500 Newton per mm square and Es value is 2 into 10 to the power of 5 Newton per mm square. If you substitute these values, my dear, you will get XU max equal to 0.46 D. But simplification in examination hall without calculator, it is difficult. So better to remember XU max value is 0.53 D for Fe 250 grade steel. XU max value equal to 0.48 D for Fe 415 grade steel. XU max equal to 0.46 D for Fe 500 grade steel. Remember this, because simplification without calculator in examination hall is highly difficult. They asked for Fy equals to 500, means for Fe 500 grade steel, XU max upon D, you will get 0.46. Option B is correct. Let me tell you one example. How to make more number of questions from the previous year questions. Suppose in previous question, if they asked XU max upon D for Fe 500 grade steel, you don't learn only that one. You have to try for the remaining grades of steel also. Because once if they asked for Fe 500, maybe in future they will ask for Fe 415 or Fe 250. Okay? Like that you can make more number of questions from the given question. Okay, na? Right. Next one. Next question. Side face reinforcement is provided in a beam when the depth of web exceeds. It is common question in state exams. When do you provide side face reinforcement? There are 3 different cases. If depth of web is more than 750 mm, that too beam is subjected to flexure only, no torsion, then we have to provide side face reinforcement. Okay? Magnitude also they may ask sometimes. It is 0.1% of web area. And the spacing of this reinforcement should not be more than 300 mm center to center. Here given only for flexure. Even there are 2 different cases remaining. One is depth of web more than 450 mm. We can provide side face reinforcement when beam is subjected to torsion. Side face reinforcement, same only. if depth of web is more than 500 mm, in pre-stressed concrete, we will provide side face reinforcement, but spacing is not more than 200 mm. It is not 300 mm, it is 200 mm only in pre-stressed concrete. Here, if you observe, 450 mm is there, 500 mm is there, 750 mm is there. But they have not mentioned in the question whether beam is subjected to flexure, or beam is subjected to torsion, or beam is subjected to pre-stressed concrete, or is it a pre-stressed concrete beam. They have not mentioned in the question. If nothing is mentioned, you have to consider this one. Beam is subjected to flexure because beam is a flexure member. If it is a torsion, 100% they will mention in the question. If it is a pre-stressed concrete beam, 100% they will mention in the question. If nothing is mentioned in the question, you have to consider beam is subjected to only flexure, then pick up option D. Is it okay? Fine. Then next one. As compared to working stress method of design, limit state method takes concrete to options given here. A higher stress level, B, a lower stress level, C, the same stress level, D, sometimes a higher but generally lower stress level. They are asking about stress in concrete in two different methods, right? One is working stress method. Wait a minute. One is working stress method. Other one is limit state method. They are asking regarding stress in concrete. Stress in concrete. In working stress method, design stress will be sigma CBC, that we can write FCK upon 3. FCK upon 3 we can write down as 0.33 FCK. In limit state method, my dear, we can take design stress as FD equal to 0.67 FCK upon partial safety factor for concrete is 1.5. After simplification, you will get 0.446 FCK. Now compare these two values in working stress method as well as in limit state method. In limit state method, concrete takes a higher stress level compared to working stress method, right? Or you can understand like this also. We are permitting more stress in concrete in limit state method as compared to working stress method. Yes, you can understand like that also. My dear, as compared to working stress method of design, limit state method takes concrete to a higher stress level. Okay, right. Next question. XU by D is a greater than limiting value of a section is designed as. Limiting value means for a balanced section. XU by D is a greater than XU max upon D. If XU upon D greater than XU max upon D, then it is over reinforced section. The question is, this section is designed as. We don't design because over reinforced section fails suddenly. Nature of failure is brittle, sudden. That's why we don't design this section. Either we can go for, we have two options. Either we can go for redesign the section or we can go for doubly reinforced beam. In these options given, under reinforced, over reinforced, redesign, balance section, we don't design over reinforced section. They are not asking which section is it. If they asked which section is it, definitely answer option B. But they asked the section is designed as, we never design. It is redesigned. Option C is correct. Try to understand the question. Otherwise, easily will commit the mistakes. In state exams, questions are not difficult, but they will confuse easily because of the framing of statement in a question. Be careful, understand the question clearly. If you are not understanding, read once again, not a problem. Don't do silly mistakes. Okay, right. Next question. Here xu by d is a greater than xu max upon d. Suppose if xu by d is a less than xu max upon d, therefore it is under reinforced section. Yes, we can design under reinforced section, no problem. xu upon d is equal to xu max upon d. Yes, it is a balanced section. Yes, we can design balanced section also, but we don't design over reinforced section because nature of failure is sudden, brittle failure. It won't give any prior warning before failure. Coming to the next question. The minimum tension reinforcement of Fe 500 steel in a 250 mm wide beam of 400 mm effective depth. Grade of steel given Fe 500. So yield stress will be 500 Newton per mm square. Width of beam given 250 mm. Effective depth of beam given 400 mm. They are asking minimum tension reinforcement. Either you can expect a formula or you can expect numerical question. Minimum tension steel, either formula or numerical question you will expect in exam. Okay, it is AS upon BD equal to 0.85 upon Fi. Right, here you can write AS upon, what is a B? 250 mm. What is a D? D is 400 equal to 0.85 upon Fy is 500. Now simplify. 250 ones are 250 twos are. 2 ones are 2 200s are. Now send 200 this side. 85 into 2, 170 will get. 170 mm square. Right? Maybe they will ask minimum tension steel or maximum tension steel also they will ask. I'll give only here maximum tension steel. I'm not going to give any solution. Just formula I would like to write here. Maximum tension steel in beams. Maximum tension steel in beams. It is not more than 4% of gross cross-sectional area, that is 0.04B capital D. Similarly, maximum area of compression steel. Maximum area of compression steel in beams. In a beam. It is not more than 0.04 into B into capital D. Definitely they will ask one question from these three formulas. From these three specifications from code, you will expect one question. Right? Either minimum tension steel or maximum tension steel or maximum compression steel in a beam. Sir, what about minimum compression steel? No recommendation from IS code. Of course, it will be 0 also. Option for this question B is correct. Okay? Right. Next question. In a RCC beam, as the tension steel increases, then actual depth of neutral axis, options given A, decreases, B, increases, C, remains same, D, none. Here, if they mention singly reinforced beam, then it is very easy to understand, right? Anyway, XU is equals to 0.87 Fy AST upon 0.36 FCK into B. XU and AST are directly proportional. So as you increase area of tension steel, XU value increases. So option B is correct. Next question. The maximum strain in compression steel of a doubly reinforced beam is, options given here. Maximum strain in compression steel. Maximum strain in concrete is 0.0035. Definitely the value should be less than 0.0035. It is 0.002. We have to place the compression steel in between 0.002 and 0.0035. So option D is wrong, option C is wrong. Maybe option A is correct or option B is correct. This is epsilon C. Let us say this is neutral axis. This is XU. Okay. This is a D dash. This is XU minus D dash. XU minus D dash. If you take similar triangles, then you will get epsilon SC 0.0035 into 1 minus D dash upon XU. Option B is correct. Next question. A doubly reinforced beam is considered less economical because options given: tensile steel required is more than that of a balance section. B, compressive steel is under stress. C, shear reinforcement is more. D, concrete is not stressed to its full value. Option C is not related to this question. We are talking about doubly reinforced beam, right? In that we have to provide shear reinforcement, but this question is related to flexure only. Okay, right. Here, my dear, stress in compression steel, we permit less than 0.87 Fy. That's why it is considered as the less economical. We are not going to utilize the compression steel effectively. That's why doubly reinforced beams are less economical as compared to singly reinforced beams. Option B is correct. Next question. What is the assumption in steel beam theory of doubly reinforced beams? Only steel bars will resist tension, only concrete resist tension, stress in tension steel equal to stress in compression steel. D, both concrete and steel will resist compression. According to steel beam theory, the stress in tension steel must be equal to stress in compression steel. Okay, it is only assumption. Stress in tension steel equal to stress in compression steel. Option C is correct. Next question. A footbridge isolated of simply supported has a slab of 3 meter width. The central supporting beam is of 6 meter length. Width of web is 250 mm. The effective width of flange is, we have 4 different formulas in flanger beams to find out effective width of flange. Here they have given footbridge. Footbridge is an example for isolated T-beam. So for isolated T-beam, effective width of flange formula is L0 upon B plus 4 plus BW, which is not more than actual width of the flange. Here L0 is distance between zero moments. Here given simply supported beam, my dear, L0 equals to L in the absence of data. If L0 given, then okay, we can take direct value. If L0 is not given, then we can take for simply supported L0 equals to effective span. So here L given 6 meters, 6 meter upon 6 meter, B given 3 meters. This is L, this is B, and this is BW. Okay, right. Plus 4 plus BW is 250 mm given, we can write in meters because everything substituting in meters. Be careful with units. 3 ones are 3 twos are 2 plus 4 6 6 6 gets cancelled. 1.25 meter. What is the B? B is 3 meters. No doubt it is less than B, therefore okay. 1.25 meter is the effective width of flange. Okay, right. Next question. A T-beam behaves as a rectangular beam of width equal to its flange if its neutral axis, options given: A, coincides with the centroid of reinforcement, B, coincides with the centroid of T section, C, remains within the flange, D, remains in the web. Suppose if you take a T-beam section, like this, this is a steel reinforcement. Whenever neutral axis lies within the flange, then section is treated like a rectangular section because concrete is effective only in compression zone. Below neutral axis in tension zone, only steel will take care of all tensile stresses. It is the assumption, right? We don't bother about the shape in tension zone. We have to consider shape only in compression zone. In compression zone, shape is rectangle. Below neutral axis, we are considering steel. Overall, we considered a T-beam like a rectangular section. When? If neutral axis lies within the flange. Suppose if neutral axis lies in the web, then you can consider like a flanged section. Remains within the flange. If neutral axis remains within the flange, then treated a flanged section like a rectangular section. Next question. An RCC beam of 200 mm by 300 mm effective subjected to a factored shear force 30 kilonewton, the maximum nominal shear stress in Newton per mm square as per present code is. We have two different formulas for nominal shear stress. One is Vu upon Bd. Another formula is Vu plus or minus Mu upon D tan beta upon Bd. Second one, only formula you can expect. First one, either formula or numerical question you may expect in exam. Here given Vu is 30 kilonewton, that is 30 into 10 cube upon Bd. B is 200, D will be 300. So how much you are getting? It is how many zeros? Total 4 zeros in the denominator. Here also 4 zeros gone, 3 gone, 1 by 2, 0.5, calci not required, 0.5 Newton per mm square. Option A is correct. Okay. There is another formula to find out nominal shear stress. Maybe they are going to ask this formula directly, but you don't expect numerical question based on this formula because it requires more time. Okay. Then next question. If the nominal shear stress tau V at a section does not exceed the permissible shear stress tau C, minimum shear reinforcement is still provided. Shear reinforcement is provided to resist the nominal shear stress. C, no shear reinforcement is provided. D, shear reinforcement is provided for the difference of 2. My dear, tau V does not exceed tau C. That means section is safe from shear point of view. In this case, no need of design shear reinforcement, but we have to provide at least minimum shear reinforcement to keep the main steel in position. Okay, right. Minimum shear reinforcement still provided even though section is safe from shear point of view. Minimum shear reinforcement we have to provide. Next question, the permissible shear stress in concrete for beams without shear reinforcement. Without shear reinforcement depends upon percentage of tension reinforcement, grade of concrete, Both of the above? None. Here we have two permissible limits. One is a tau c, another one is tau c max. Tau c depends on two things. One is concrete grade and percentage of tension steel, 100 AST upon BD. Tau c max depends on only concrete grade. Depends on only concrete grade. If they give tau c and tau c max, easily you will identify. If they have not given tau c and tau c max notations, then how do we identify? In tau c, my dear, we don't consider shear reinforcement. In tau c max, we consider shear reinforcement. Okay, na? Right. So, here without shear reinforcement, so question is related to tau c. Option C is correct. Next question. The lap length in compression is not less than LDR 35, 2 times LDR 35, LDR 24.5, 2 times LDR 24.5. Lap length in compression. Actually, in flexural tension, lap length will be LDR 35, whichever is maximum. In direct tension, lap length will be 2 times LDR 35, whichever is maximum. In compression, lap length required is LDR 24.5, whichever is maximum. Here they asked in compression, so option C is correct. Maybe you will expect for a direct tension or flexural tension in exam. That's what I am telling. If you want to make more number of questions, in previous year, if they asked for one particular case, you try for other cases also. Because once they asked a question from particular area, from the same concept, next time there is no guarantee that same question will be appeared. If same question appeared, you are a lucky fellow, right? Otherwise, unnecessarily you are going to lose the marks, right? So you try for other cases also for the same concept. Next question. For full anchorage, the stirrups should extend by a length of dash times the diameter of the bar when bent at 135 degrees. Options given here. For stirrups of 135 degrees bend, anchorage value will be 6 times bar diameter. If it is a tension steel, 12 times bar diameter. Okay, right. Next question. Which one of the following statements is correct? In a reinforced concrete member, the best way to ensure adequate bond is, the best way is providing smaller diameter bars more in number. Here provide large number of smaller diameter bars given. Yes, option B. Why? Whenever you choose smaller diameter, you will get more numbers. If numbers are more, then surface area in contact with the concrete will be more. So bond stress will be more. Bond stress will be more. Next question. Equivalent shear VE is given by VU plus 1.6 TU upon B. It is a direct formula. VE equal to VU plus VT. VU plus VT as an empirical formula recommended by IS code 1.6 TU upon B. Direct formula. Either this formula or a numerical question, or sometimes they will ask equivalent bending moment MU plus MT. MU is the factored bending moment. MT is the torsional moment due to torsion. That is TU into 1 plus capital D by B upon 1.7. Maybe they asked for equivalent shear force. Maybe you can learn for equivalent bending moment also. Option A is correct for this question. Next question. Match list 1 with list 2. This type of questions easily you can answer. Truss analysis, my dear, is based on skew bending theory. A given to A2 given either B or C. So D is wrong, A is wrong. Then shear stress analysis B1, here B1 given, B1 given, so there is no chance. Limit state method is a partly based on probability, partly based on empirical approach, so it is semi-probabilistic approach. C3, option B is correct, decided. Working stress method, no doubt, deterministic. Okay, next question. The minimum thickness of a flat slab required according to IS 456-2000. It is also famous question. It's a direct one, 125 mm. Next question. The torsional reinforcement in a two-way restraint slab required for a corner with the two continuous edges. Two continuous edges will be at any corner. If both edges are discontinuous, torsion steel required is 3/4 of ASTXX. At any corner, one edge is continuous, another edge discontinuous, torsion steel required is 3/8 ASTXX. At any corner, both edges are continuous, no need of torsion steel. Here, with the two edges continuous, so no need of torsion steel. Okay, next question. The permissible value of deflection for a two-way simply supported slab with a shorter span less than 3.5 meter and live load 3 kilonewton per meter square using deformed bars. L by D value, my dear, for a simply supported slab is 35. It is for mild steel. If you want for HYSG bars, multiply with 0.8. It is 28. Option B is correct. They asked deformed bars. Otherwise, it is 35. L by D ratio for two-way slabs. For simply supported slabs, L by D ratio is 20. The minimum number of bars in a circular RC column is, it is also one of the famous question in state exams. Minimum 6 numbers in circular column. In rectangular column, minimum numbers 4. In polygonal columns, 1 at each corner we can provide. An axially loaded column is of 300 mm and square inch section. The effective length of the column is 3 meters. What is the minimum eccentricity of the axial load for the column? They are asking minimum eccentricity. Minimum eccentricity can be find out like this. Unsupported length of column upon 500 plus B upon 30 or 20 mm, whichever is maximum. Here unsupported length of column not given, so you can select effective length as unsupported length. That is 3 meters given, write in mm, 3000 upon 500, B given 300 mm upon 30. If you simplify, 2 zeros, 5 ones are 5 6s are 0 0, 3 ones are 3 10s are. So total you will get 16 mm. Compare 16 mm with the 20 mm. Take maximum of these two. 20 mm is the minimum eccentricity. Even without calculation also you can pick up how means minimum eccentricity required 20 mm. No option is given more than 20 mm. So maximum is 20 mm, given one of the option. Pick up directly. The purpose of lateral ties in a short column is, it is also one of the famous question in state exams, right? Main reason to provide lateral ties is to avoid the buckling of longitudinal bars, to keep the main steel in position. Next question, the minimum thickness required at the edge of a footing according to IS 456-2000 is, they have not mentioned whether footing is resting on soil or footing is resting on piles. If nothing is mentioned, then you can choose footing is resting on soil, right? Because required least edge thickness for footing when it is resting on soil. So 150 mm you have to pick up, 150 mm. If footing is resting on piles, minimum edge thickness required is 300 mm. Luckily that 300 mm is not there in options. If 300 mm is there, then you will get doubt which one I have to pick up. 300 mm, 150 mm. Which is the least? Least is 150. Pick up 150. Whenever they have not mentioned whether footing is resting on soil or piles, you have to pick up the option like that. In case of isolated square concrete footing, match the location at which the stress resultant are to be checked. Where is a critical section for these stress functions? Options given like this. For bending moment, critical section lies exactly at the face of the column. P1. P1, P1. So option B is wrong, option D is wrong. One-way shear. For one-way shear, critical section lies at a distance D from the face of the column. Q2. Q2. No, Q3. I'm sorry, Q3. Q3 means A is wrong. Right. For punching shear, critical section lies at a distance D by 2, where D be the effective depth of footing. Next question. The permissible bearing stress for M20 concrete of column resting on a rectangular concrete footing in limit state method of design should not be more than. Permissible bearing stress in limit state method is 0.45 FCK. Given M20 grade concrete for which FCK equal to 20 Newton per mm square. Now substitute here 0.45 into 20. You'll get 9 Newton per mm square. Option B is correct. Next question. Match list 1 with list 2. This type of questions easily you can answer if you know two things from this. Flexure, shear, bond, deflection. Given under list 1, under list 2 given minimum depth of section, longitudinal steel reinforcement, stirrups, anchorage in support. Okay, by reading 1, 2, 3, 4 given under list 2, you can understand which are given to resist this. Okay, for flexure, to resist flexure, you have to design longitudinal steel reinforcement. P is 2, here P2, P2, P2. So A is wrong, C is wrong, 50-50 chances. Then shear, stirrups, Q3, Q3, both are given same. Then bond, to satisfy the bond, you have to maintain anchorage in support. 4, R4, R4, option D is correct, B is wrong. That's all. Easy to pick up this type of questions. Next question. A cantilever slab is of span 1.4 meter. The thickness required from serviceability criteria is. In order to satisfy the serviceability criteria, L by D values you must follow. Maximum L by D value for cantilever is 7. They are asking what is the thickness required. D is equals to L by 7. What is the L given here? 1.4 meter. Write in mm. Upon 7. It is 200 mm. Yes, thickness required 200 mm. Okay. Next question. Shrinkage deflection in case of rectangular beams and slabs can be eliminated by putting. How do you eliminate shrinkage deflection? Very simple. You can place steel in tension zone as well as in compression zone with the equal magnitude. Shrinkage deflection can be 0, or shrinkage deflection can be eliminated by putting equal steel in tension and compression zone. Option A. Next question. As per Indian Standard Code of Practice for pre-stressed concrete IS 1343-1980, the minimum grades of concrete to be used for post-tension and pre-tension structural elements are respectively. Commonly asked question in state exams. Here they asked for post-tension and pre-tension. Order important, respectively order important. First you have to pick up for post-tension, next for pre-tension. For post-tension M30, for pre-tension M40. Option D is correct. Okay, right. Next question. The minimum compressive strength of 100 mm cubes of grout in pre-stressing tendons should not be less than. We have to test the cubes of size 10 centimeter, and the strength we are expecting at 7 days not less than 17 megapascal. There are 3 different sizes of cubes. One is 15 centimeter, another one is 7.06 centimeter, another one is 10 centimeter size cube. It is for concrete, to decide concrete grade, to decide cement grade, to decide cement grade, and it is to find out grouting material strength, to find out grouting material strength. Okay, right. Option A is correct. They are asking at how many days you have to test, what is the strength you are expecting. 7 days, 17 megapascal. Next one, a pre-stressed concrete beam is loaded with 2-point loads. The profile of cable is laid based on the load balancing concept. The shape of profile is, whenever the beam is subjected to 2-point loads like this, the bending moment diagram will be trapezoidal shape. Similar to the shape of the bending moment diagram, we have to select shape of the cable. So trapezoidal. For load balancing condition, the shape of cable selected based on the shape of bending moment diagram. For the 2-point loads, shape of bending moment diagram is trapezoidal. So you can select the shape of cable as trapezoidal. Next question. A concrete beam of a rectangular cross section of 200 mm by 400 mm is pre-stressed with a force of 400 kilonewton at an eccentricity of 100 mm. The maximum compressive stress in the concrete is. They are asking maximum stress. We know stress at top fiber and stress at bottom fiber. Stress at top fiber is P by A minus PE by Z. Stress at bottom fiber is P by A plus PE by Z. Whenever we place the tenon with eccentricity E, then stress developed at top fiber is P by A minus PE by Z, and the stress developed at bottom fiber is P by A plus PE by Z. They are asking maximum stress. Maximum we can get from plus sign. So P is here 400 kilonewton. We can write 400 into 10 cube upon area 200 by 400 plus 400 into 10 cube into eccentricity will be 100 upon Z is 200 into 400 square upon 6. Simplify, 400 gone, 200 ones are 200 fives are. Answer should be more than 5. Option D wrong, option C wrong. Maybe B is correct or A is correct. Let us check this. 400 gone, 400 gone. 200 ones are, 200 fives are. Now 400 is still remaining. 2 zeros. 4 is remaining. 5 into 6, 30. 30 by 4. 15 by 2. 7.5. 5 plus 7.5. 12.5 is answer. Not required calculator. 1 minute is sufficient to solve this question. Option A is correct. Next question. In a pre-tension beam, which of the following losses is or not considered? Under pre-tensioning method, we don't consider anchorage slip loss, even friction loss also we don't consider. These two losses considered only under post-tensioning method. Here anchorage slip loss, yes, it is not considered. Relaxation considered, shrinkage considered, friction not considered. Creep considered, even elastic shortening will be considered. 1 and 5. Option C is correct. Next question. A pre-stressed beam of length 20 meter has an initial stress of 1000 megapascal. During tensioning, the jack slips by 2 mm. If ES equals to 200 gigapascal, the loss of stress due to slip is, slip means anchorage slip. It is also famous question for state exams. Not only for state exam, for all types of competitive exams, this question is important. Right. They are asking percentage loss. First of all, we have to find out loss of stress due to anchorage slip. That is delta upon L into ES. Delta will be given 2 mm. Length given 20 meters, right in mm. Into ES given 200 gigapascal, right in megapascal. 1 gigapascal is equals to 10 power 3 megapascal. 1000 gone. 20 ones are 20, 10s are 2 into 10, 20. We are getting 20 Newton per mm square. What is this? It is a loss. But if we observe the options, they are asking percentage. Percentage loss is equals to loss of stress upon initial stress into 100. Loss will be 20. Initial given here 1000 megapascal, 1000 into 100. Now 3 zeros gone. 2% is the loss. Option B is correct. Next question. As per IS 1343, total shrinkage for pre-tensioned beams is 3 into 10 to the power of minus 4. Either for pre-tensioned beam or for post-tension. For anyone you may expect in exam. For post-tension, shrinkage strain is 2 into 10 to the power of minus 4 upon log base 10 into T plus 2. It is a shrinkage strain in concrete under post-tensioning. Under pre-tensioning, 3 into 10 to the power of minus 4. Next one, if the retaining wall is not safe in sliding, then what to do? Best option, provide the shear key. Whenever retaining wall is not safe, then provide the shear key. What is shear key? You see, this is a retaining wall. Here, some extra projection is provided. This is a shear key. How do you know it is not safe? We can check the factor of safety. This factor of safety value is coming less than 1.5. Then we can say it is not safe in sliding. In that case, provide shear key. Next question. The minimum factor of safety against overturning of RC retaining wall. Factor of safety for overturning will be 2, for sliding will be 1.5. Anyone you may expect in exam. Next, I wish you all the best. I have discussed here few questions, not all the questions. I told you how to increase the number of questions. You just follow that method. You will get n number of questions. Okay, all the best.
Online test series from ACE online platform and used to regularly solve their subject-wise test and full-length test. Then for mains preparation, I solved question banks which were given to me as a part of mains postal program from ACE online. And then last but not the least, for interview preparation, I followed the interview guidance material which was given to me as a part of ACE online's interview guidance program.
I am Vinit Kumar. I have secured All India Rank 1 in Mechanical Engineering in ESC 2021. I have been associated with ACE Engineering. I have taken various programs like Lives, main classes, postal study course, test series and interview guidance program. So would like to thank all the faculties of ACE. It has helped me in building my concepts and having my fundamentals cleared. I would also like to highlight that in test series, I have given various mock tests which have helped me in the time of real exam, and in interview guidance program, building confidence in front of interview panel. It has helped me in my success.
Myself Abhishek Kumar Sharma. I have scored All India Rank 1 in UPSC Engineering Services Examination 2021 in Electrical Engineering discipline. Now I divide my preparation strategy into 3 basic things. The first thing is that you have to complete your syllabus from a basic standard source. The second thing is that you have to attempt previous year question. The third thing aspirant has to do is to solve as many test series as possible. I made 2 to 3 pages short notes of each and every subject. Now 2 to 3 pages short notes help in quick revision. If you keep working hard, you will definitely get success in this examination. This is what I followed, and I wish all the best for all the future aspirants. Thank you.
My name is Kuldeep. I have done my BTech from Ambedkar Institute of Technology, which is situated in Delhi, and I have secured All India Rank 1 in ESE 2021 from E&T branch. I took ACE Postal Course, Mains Test Series and Interview Guidance Program in ESE 2020 and ESE 2021.
Hello everyone, my name is Karthikeya Kaushik and I have secured All India Rank 1 in UPSC Engineering Services Examination 2021 from Civil Engineering discipline. For prelims preparation, I took online test series from ACE online platform and used to regularly solve their subject-wise test and full-length test. Then for mains preparation, I solved question banks which were given to me as a part of mains postal program from ACE Online. And then last but not the least, for interview preparation, I followed the interview guidance material which was given to me as a part of ACE Online's